So we're going to talk about properties of quadratic graphs today. We're going to look at just the graph today and find some important pieces. Tomorrow I'm going to give you the equation, and you'll use the equation to find the important pieces. Okay? So we're going to start out with the graphs because some of these vocabulary words are easier to recognize when you have something to look for visually. Okay? All right. So we've talked about standard form of a quadratic. But to review, the standard form of a quadratic is y equals ax squared plus bx plus c. A quadratic function is always going to have this x squared component. Okay? The x squared is what gives the graph its shape. The parent function of a quadratic, y equals x squared. So just like when we had lines, the parent function for a line is y equals x. The parent function for a quadratic is y equals x squared. All right. What I meant by the x squared gives the quadratic its shape. That shape we call a parabola. A parabola. No, it's pronounced parabola, but yes, you could call it parabola if you want. And it's interesting that you call it parabola because it kind of looks like a bowl. So it's interesting that you bring up that point. So it looks like a bowl, or a lot of people refer to it as U-shaped. U-shaped. It looks like a U.
I knew you were going to say that. Oh my God.
You like the letter, not Y-O-U, as in you, Marcus. Ah, there we go. Does that clarify? Hang on. We're going to get there. All right, so, some of them are skinny, some of them are wide. It depends. We're going to talk about what gives it those characteristics later. But for today, we're just going to talk about some important points, okay? So every parabola has either a maximum or a minimum. So a maximum means it has a topmost point. A minimum meaning, yes sir.
This one never ends because it has an arrow in it.
Ooh, interesting. I'm going to pause right there. You mean this example here?
Yeah.
Ooh, it does have arrows. So it's going up forever or down forever?
Up forever.
Up forever. So this one's going up, 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 up. So it doesn't have a topmost point, right?
No.
But does it have a bottom?
Yeah.
So this particular example is going to have a minimum, a bottommost point. That is a very good point there. Huh? Point? We're talking about points? Sorry. Huh? All right, domain and range. Domain and range is a bit of a review. We've talked about domain and range earlier this year, right? So domain, just to review, is all of the x values. Range is all of the y values. All of the x, range is all of the y. All right, so I'm going to list some of these important points here on my example. Now, I did forget to label my axes, so if y'all would help me here. I'm going to label the axes. So the vertical axis is, the vertical one is Y. The horizontal one, Jules, is X. There you go. Sorry. Y and then X. So I have my parabola here. Nope, wrong. There we go. I have my parabola here. So the first thing I want to point out is that vertex, because we already kind of talked about that, right?
Yeah.
I'm going to zoom out just a smidge. There we go. So this point here is my vertex.
You didn't finish the X.
Oh. There we go. All right, the vertex. Oh, I was doing vertex in red. The vertex is located at a coordinate point. I'm going to call this point XY because I'm not sure exactly where my example vertex is. XY. Put your phone away, Marcus. All right, we said this particular vertex was a minimum because it was at the bottom of the bowl, right? Oh, this one would be negative. Yes, that Y value would be negative. And we're going to do lots and lots and lots of examples. So in this particular example is a minimum. Because it's at the bottom. Very good. So it's at the bottom, so my vertex is at the bottom, like you said. And then my arrows, my endpoints are pointing up, like Marcus pointed out earlier. So it's going up forever, right? Forever and ever and ever going up because the arrows are pointing up. Okay. I have a dotted line here drawn right down the middle.
It's a function.
It is a function because that dotted line, no matter where I moved it, it would only cross through that parabola once, right? Well, this one, I did draw in a special place right down the middle because a parabola is special in the way that it's symmetric.
On both sides.
So all the points that are on the left side, all of those Y values that are on the left side are also on the right side, just with a different X value. So if I took this parabola and folded it in half, these two sides would be right on top of each other. So that dotted line has a special name. It's called the axis of symmetry. The axis of symmetry. All right, and my axis of symmetry, it doesn't matter if my graph is pointing up, or if it's upside down and pointing down, right? My axis of symmetry is going to be a vertical line. So what does the equation for a vertical line look like? Is it x equals or y equals?
Why?
Well, y equals means the line would go this way through the y-axis, right?
X equals.
X equals because it's a vertical line, it's going through the x-axis. So we're going to say x equals some number, and actually it's specifically that x value from your vertex. Always. And we're going to do example here in a minute. Candy away. Unless you're trying to give it all to me, put your candy away. All right. So let's see here. Domain and range we talked about next. But before that, I wanted to talk about, a parabola, like a line, has a Y-intercept. Your Y-intercept is going to be labeled as a coordinate point, so we're going to have your X value is always 0 on your Y-intercept, right? Because see here, what's the x value on the y-axis? 0. So it's 0, comma, that y value. All right, last thing before I give you an actual parabola and we find some fun stuff about it. You ready? We're going to talk about domain and range one more time. One more time. So the domain of a parabola. Well, we'd pointed out right away that this is going up, up, up on the left side, up on the right side, yes? But look here, if it's going up and it's going slightly to the left on the left side, isn't it? So as long as it goes up, it's also going to go left. So do I have a smallest x value? If it's always going just a little more to the left? Well, that's a trick question, right? No, it doesn't have a smallest x value. What do we call that when we don't have a smallest x value? Negative infinity, right? Comma. And then if I'm going up and to the right, so as long as I go up, I go slightly to the right, am I ever going to have am I going to get to the biggest x value? Never. So my domain is going to go from negative infinity to positive infinity. All right. What about the range?
Don't you get like the biggest and the smallest?
We want the biggest and the smallest y value, right?
Yeah.
So we start with the smallest. Here, does this have a smallest y value?
No.
Well, here, if I have a minimum value, then I do have a smallest value, right? So what's my smallest y value? It's whatever the y value is here in the vertex, right? So I'm going to say y, comma, and if it's pointing up, am I going to have a biggest y value? No, because it's always going up. So we're going to have y to infinity. And that will look a little different if we have a maximum value instead, and I'm going to show you an example of both right now. You ready? All right. So example 1. So I've got 6 questions about this parabola, all of which I can answer by just looking with my eyeballs at the graph. You ready?
Yeah.
So, Robin, you say this one has a maximum?
Yes.
Why? Because it's facing down, so it's got a topmost point. That's perfect. Maximum. You got this. You don't mind if I'm lazy and just circle maximum?
No.
Okay. There you go. Then you can be lazy too. We're going to circle maximum. Now, the vertex is where is that maximum located? Oh, a maximum? It's going to be a coordinate point, right? So what's the x value of that coordinate point? 1. And what's my y value? Negative 3. Bless you. So far, so good?
Yeah.
All right, my axis of symmetry is going to go right through that vertex.
Jules.
Is that okay?
Yeah.
It's going to go right through the vertex.
Want us to draw that?
You don't have to. I did because I know that that's where my vertex is going to be. I mean, where my axis of symmetry is going to be because it's going to go through the vertex. So I said, well, the axis of symmetry is always going to be x equals, and it's going through 1 on the x-axis. Also notice that's the same as the x value in my vertex, right? I said those two are always going to be the same, right?
Yeah.
All right.
So So is that X and Y right there, the vertex?
Yes. This is your X and your Y value for that vertex. So I went positive 1 over 1 to the X and down 3 to get to that vertex. Is that better? All right. The Y-intercept, where does this graph cross the Y-axis? -4. So do I write just -4?
No.
No, I want to.
Yeah.
So what's that X value?
1.
No, 0. Because it's right in the middle, right? And we go down 4, so that's -4. All right. Last part, domain and range. You ready? So my domain, my graph is going down to the left, down to the right, but as long as it's going down, it's going slightly more to the left and slightly more to the right. So are we ever going to get to the biggest and smallest X values? No. So what's my domain? -infinity to +infinity. Always. All right, let's talk about that range. It's pointing down, so your Y values. So if I look down, am I going to have a smallest Y value? No, because it's always going to go further down, right? So do I have a smallest Y value? No. So my Y value is going to be -infinity to, and we go up, 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 up. What's my biggest?
-4.
My biggest Y value? -3.
Oh.
Look, look, look.
negative.
-4 was your Y-intercept, right? Look, there's Y values bigger right here, -3, right? So to -3. And -3 is included, so we're going to write a bracket instead of our parenthesis. Yes?
Wait, why a bracket?
Because that value's included.
Oh.
We talked about that a little bit when we did remember the inequalities. Very good. All right, I want you guys to try example 2. I'm going to give you about 2 minutes, then we're going to talk about it. All right, you guys, let's take a look at example 2. I gave you a few minutes to work this on your own, so now let's check our work. You ready?
Yeah.
So my parabola, is it pointing up or pointing down?
Down, so it's minimum.
It's pointing up, so it has a bottom, right? There we go. I know what you meant. So we have a minimum. So where is that vertex located?
-2, -1.
-2, -1. Very good. My axis of symmetry is going to be x equals,
-2.
beautiful, -2. Next, it asks about the y-intercept. So I put a point there where that parabola crosses the y-axis.
Would that be a
0,
zero?
comma,
-3.
-3? +3. Very good. We've got this. All right, what about my domain? What are the x values that this parabola takes up?
-8.
-infinity to +infinity. So your domain, so here's kind of a cheat, you guys. All of our parabolas, the domain is all real numbers for all parabolas. It's always going to be -infinity to +infinity. Okay? All right, what about the range? What's my smallest,
-infinity.
my range? What's my smallest y value?
-2.
Not -2. What's that y value? -1.
To infinity.
Oh, I made a mistake. And it is to infinity because it always goes up.
I'm just so smart.
Example 3 got cut off. We're not going to worry about example 3.
I'm really smart.
I'm going to send you guys the practice right now.